What is up, everybody? And we are live. We are back after a little bit of a hiatus from KubeCon. KubeCon was intense. Massive shout out to everybody who attended DoK Day. It rocked. It was incredible. It feels like it was 10 years ago. It was actually just a couple of weeks ago. Anyway, we are back as usual, the Data on Kubernetes community. We got a lot of stuff going on. So before I introduce our oh so special guest, who is a Data on Kubernetes OG, his name starts with A. So when I got started in the DoK community a long time ago, the first thing I did is I went to Slack and I just started looking at, different people. And luckily enough, this person's name starts with A. So it's one of the first people I talked to. We'll get to him in a second, because one of the things that's actually related to today's speaker is the DoK landscape, which is something that we announced in DoK Day and KubeCon. By the way, if you want to see all the talks from DoK Day, they're all on YouTube, so you can get access to that. Speakers in our Slack, if you got any questions, you could always reach out and ask them there directly. But first and foremost, I do want to share the DoK landscape so you can take a look. For the folks that are in our community, you will be able to see the different technologies. There are some that we're still adding, but the different technologies that are part of the Data on Kubernetes community ecosystem, right? Our landscape's not as big as the CNCF's landscape. That's not a problem, right? It's easier to navigate. You can check by categories. You can see the different stuff that you can use to be able to put Data on Kubernetes into practice. And of course, if you got questions, reach out in Slack. All these people are very accessible. Speaking of accessibility, we are doing more and more in-person meetups, and our next one is coming up on June 30th in London. If anyone's in London, you are more than invited. It's totally free. We're going to have a super cool panel as well as some lightning talks. And so that'll be on June 30th in London. So please check that out. We've got Canonical, we've got Ondat, we've got SUSE, we've got an end user from Accenture who's going to be attending. Also got a speaker from EDB. Got another speaker lined up from Terminus DB. So anyway, that's going to be action-packed. If you're a Data on Kubernetes community member or sponsor, massive shout out to our sponsors, and you would like to host an in-person event, let us know, in person or online. That's cool too. In any language, in any part of the world, just reach out to me on Slack and we'll make that happen. One other thing that I do want to mention is that we also have another live stream tomorrow. Yeah, we're getting pretty ambitious about our live streams again. So you can expect to see at least 2, if not 3 live streams per week. Tomorrow, we're taking a panel further, right? Because we did this in the DoK Students Day, but it was only about 20 minutes. So we didn't exactly get to cover all the stuff that we wanted to cover. And this panel is about a very special topic, which is diversity, equity, inclusion, something we could always do better. So please take a look at that. We've got 6 amazing speakers. I'm just going to be hanging out in the background, behind the scenes, fielding questions from the audience, but 6 super cool speakers. So please check that out. Like I said, that will be tomorrow at our regular time, 6 p.m. here in Spain, 9 a.m. in California, other times in other parts of the world. Anyway, speaking of other parts of the world, man, everything's connected today. This person, I believe, has given over 110 talks. He will have to confirm that. But like I said, total Data on Kubernetes veteran, super generous with his time, a person who gives really, really good talks. I've seen him give talks in English and Spanish. He's so good at giving talks that I'm going to propose this now. I would like Álvaro to give a talk about how to give a talk, right? Because giving a talk can be overwhelming. It's not to say there's only one way to do it, but there are certain techniques that will really, really help you better connect with your audience. And I think he's got a ton of these very well down as a natural way of connecting with audiences, making complex concepts easier to understand. And that's exactly what he's going to be doing today with his very ambitious live stream and demo that he'll be leading. So that being said, I will use the magic words to bring Álvaro on stage. And those magic words are Postgres, Postgres, Postgres. Let's see if it works. And it did. Álvaro, how are you? You're muted.
Oh, yeah. I'm on call. Yeah, I just decided to appear first, right?
That's all good. Very good to have you with us. For the folks who don't know you, and they should know you, who are you and what are we going to be doing today?
So first of all, thank you for having me, and thank you everybody for attending this kind of crazy talk. I hope you'll have fun. I will not, because I'll suffer. You will enjoy. I'm a Postgres person. That's pretty obvious, right? That's why I respond to the Postgres word 3 times. And I basically work on doing R&D and creating very innovative projects for the Postgres ecosystem. I'll provide a little bit more details on my slide. But that's basically Postgres person. Anything Postgres, just talk to me.
Yeah, and that's true because in our community, you've done talks, you know, a workshop, you've done a panel, plenty of content of Álvaro's that you can check out. He's, like I said, he's been with us for quite a while. And when it comes to Postgres, pretty much a one-stop shop when it comes to, you know, resources, knowing what's going on, different communities, even has his own foundation that organizes events in Spain. And we're hoping to do one soon, but there will be more news about that. So don't worry about that. That being said, folks, as usual, this is an open conversation, right? He's going to be doing a demo. We're going to have different things going on here. If you're not sure about something, make sure you ask either in the YouTube chat or do so directly on Slack, just tagging Álvaro. He's very responsive. I know that because when folks have a question, I can tag him, and I know that he's going to appear quite quickly to be able to respond to whatever doubts that people might have. So that being said, Álvaro, please take it away. Share your screen. Show us the magic we're going to experience today. Very, very interesting angles, high risk maneuvers. Excited about this demo. Let's see what happens.
Awesome. Thank you so much. Just double check. Can you see the screen correctly?
Yep. Looks great.
All right. By the way, you asked me about giving a talk. I can definitely do that. I'm not sure I have any good or professional recipe. Actually, I think I follow many anti-patterns in preparing talks. So like this one, it's essentially not prepared at all. The slides you'll see are incredibly short, and everything is left for a demo that I'm really crossing all the fingers I have in my body, trying to think that it's going to work, but it will probably not. So I don't know if I can provide good recommendations, at least from experience. Yes, I'm probably over, I haven't counted, but it's probably over 120 in the last 10 years or so. Virtual made it easier to do even more. Even I tried to slow down lately. Anyway, it doesn't really matter. I'm happy to do that talk anyway. I'm trying to see what can come out of that.
Sounds good to me.
All right. So interesting thing, right? This is a talk about SQL Server, and I'm supposed to be the Postgres guy. That's what I said. So what the heck, right? It actually turns out that we're going to talk about SQL Server, but with a small caveat, which is without SQL Server. I'm sure you know how I'm going to do that, but if you don't know, just stay with me because we're going to do SQL Server without SQL Server. If you want to reach out to me, first go to the DoK Slack, just write Postgres. I'll try to appear there. I'm also available on Twitter and all usual channels. So let's get started. We're going to talk about time series on SQL Server, on Kubernetes, on ARM64, and as I said, without SQL Server. Before the compulsory slide about who am I founded and I am the CEO of a company called OnGres. OnGres means on Postgres, so it should be pretty obvious what we do, right? I've been using this database myself for more than 20 years, like wearing all hats. I've been, kind of a developer, like SQL developer, structured, queries, then DBA, administration of databases, architect, like everything you can do. And I focus most of my time, apart from managing the company, and trying to do R&D and trying to see what new things we can bring to the Postgres ecosystem. Because Postgres is kind of a fantastic database, no question about it. But I consider it kind of similar to a kernel. It's a little bit bare bones. You need the batteries. It's not batteries included. I mean, it's batteries included for if you just want to run it on your laptop. But if you want to put it into production, it really needs a lot of components around it. We call it the stack of components around it. And there's a lot of space for innovation here. So I like personally, and I also try to inspire our company to create new innovative solutions in the Postgres space. As we discussed already, I like to give tech talks, mostly about Postgres, also sometimes databases, Java topics, cloud topics. And as part of this R&D, I have kind of architected and designed two main software components. One is called Postgres, which is a platform for running Postgres and Kubernetes. The other one is StoraDB, which was, in the past I'm speaking, a project that replicate live data from MongoDB to Postgres and transforming the JSON documents into a relational structure on the fly. Interesting. And as Bart mentioned, I also founded a nonprofit organization in Spain, but with international aim, which is the Fundación Postgres, which is, yes, it's a nonprofit organization to promote Postgres around the world and who, among all activities, organizes a conference in Ibiza, pgibz.io, if you're interested. Unfortunately, it's been canceled the last 2 years. You can imagine why. The last 3 editions, actually. You can guess why, but we're coming back on 2023. At the end of June. You're more than welcome to join the best Postgres conference ever. These are not my words. And I'm also, I was named the data hero. If you go to my webpage on aht.es, you'll find all my talks, links to the slides, video recordings, blog posts, and everything. So contact information too. So let's get to the real topic today. And by the way, this is a super informal conversation. Please post any question anytime. Bart, I may ask a little bit for your help if there's questions on YouTube, just to keep an eye on them, and feel free to interrupt anytime.
Yep, no problem.
So I want to keep this talk focused on the demo part. And so just some basic concepts first before we start. The first one, time series on SQL Server. I'm not a SQL Server expert, so maybe you are, just correct me. But I've been researching who is doing time series on SQL Server. And honestly, I didn't find much. Like, there is some mentions to time series on SQL Server mentioning an algorithm, but apparently this is SQL Server Data Studio, something like this, sorry, and I'm not super expert in this area. And it's mostly about some machine learning algorithms. So that's not what we're talking here. We're talking here about storing into the database data that refers to a time dimension, typically what's called time series data. So data coming from sensors, from the stock exchange market, whatever, right? It's data that refers to a time dimension. And again, I didn't find a lot of options. Yes, there is a couple of posts here and there mentioning that you can use partitioning. This is kind of obvious. That you can use SQL Server's column store for the indexes. That also makes a lot of sense, but that sounds kind of more of a hack rather than a real solution. So again, unless my research was not done correctly, I haven't seen like a real native way of doing time series on SQL Server. So I hope that this talk will be very interesting for everybody because of the technologies involved, but especially for SQL Server users, because maybe I want to provide you a solution to do time series on SQL Server, a solution that didn't exist before, because this is bringing a native technology for doing time series on SQL Server. So far, so good. Still with me. So we're also going to run SQL Server on Kubernetes. I also did my research. And to be honest, yes, there's definitely options to run SQL Server on Kubernetes. There is containers published by Microsoft to run SQL Server on Kubernetes. I guess most of them are based on Linux, which is great coming from SQL Server that was ported to Linux. But honestly, I haven't checked in details about those containers. And so when you have a container image, it is not that difficult to make it run on Kubernetes. Now, what I haven't found is in great detail ways to run SQL Server with production quality on Kubernetes. Most of the information I have found so far is just running the container, which essentially does not provide high availability, appropriate monitoring, backups, and essentially all the components that you require for a full production environment. So today, we're going to see a solution for running SQL Server on Kubernetes that is, to be honest, is not exactly ready for production yet, will be soon, but without any involvement from you as a user. So basically, we're going to use some technologies that might not be completely mature as of today. Once they are a little bit more mature, without changing any of, for example, the deployment scripts or the way we're going to deploy it, you'll be able to get a production environment, something you can try and test today that includes monitoring, for example, and could be used for production at any moment. So let's recap. We're going to talk about time series on SQL Server, which seems quite a new concept, at least native time series on SQL Server, and then running SQL Server on Kubernetes. I hope that this is going to be interesting so far. Now, let's make it even more interesting, or at least let's make another twist. What if we ran all this on ARM64? And I mean, it's not the end of the world. It's not rocket science. There's plenty of options to run containers and Kubernetes on ARM64. But still, not everybody does this, right? And ARM64, they're great processors. They might be better or worse for some workloads compared to AMD64 architecture. But there's great processors out there in some of the clouds that offer ARM64 processors. And I just thought it was going to be cool to do this. So we're going to run this demo on the Graviton 3 new processors available on Amazon Cloud that are quite impressive in terms of performance. So we're going to run time series on SQL Server, on Kubernetes, on ARM64. Interesting. Do you know of any container built by Microsoft that runs SQL Server or ARM64? Maybe it exists. I don't know, honestly. Excuse me. And but we're not going to use it. And the funny part is, okay, if you're not going to use SQL Server containers, actually everything we're going to use here is fully open source. You can try it on your home today. So what are we going to use it? Because we're not going to use SQL Server at all. So how is it possible that I'm going to be talking about time series on SQL Server, on Kubernetes, on ARM64, blah, 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 without using SQL Server? Well, I guess you all know the answer, but just in case you don't, let me just open the browser here and show you this project, the Babelfish project for Postgres. This is the Google search away. And if you haven't heard about it, Babelfish is a project that was open sourced by Amazon and running as a community, as an open source community, just starting, that adds SQL Server compatibility on top of Postgres. So this project is open source, and as of today consists on some changes to core Postgres, plus some extensions that turn Postgres into SQL Server. It provides compatibility at 3 levels. The level of protocol compatibility, so you can use SQL Server drivers to connect to Babelfish, and that behaves as a SQL Server. So applications that work against SQL Server should or may work without changes, not even changing the driver, the connection string, anything. They should work as is. They also provide as a second level of compatibility. It provides compatibility with the SQL Server, the SQL language in SQL Server, also called T-SQL, which is its own dialect of SQL, and it provides compatibility with the SQL layer. And third, it provides compatibility with the store procedures written in T-SQL. So all these 3 compatibility components are built into Babelfish, which again is an open source product that runs on a slightly modified version of Postgres plus some extensions. And this modified part is expected to be upstream at some point to the vanilla Postgres project. So with these benefits, we are going to be able to essentially run a SQL Server compatible, I can say that with more precision, SQL Server compatible layer, purely open source that essentially runs on top of Postgres. So all the Postgres benefits and goodies and advantages that Postgres has also apply here on top of SQL Server compatibility. Now, this is good enough, but this doesn't provide time series. There's no time series, again, in SQL Server. There's consequently no time series on Babelfish. What we're going to do? Well, interestingly enough, there is in the Postgres ecosystem an extension for doing time series called timescale, right? Probably you'll know about timescale. And timescale is an extension. Postgres extensions are kind of like plugins, right? Some components that you can load into Postgres and augments the functionality of the Postgres database. So timescale is an extension that enhances Postgres functionality by providing time series capabilities. Now, Is it too crazy to combine these two ideas and to take Babelfish and timescale and put them together so that we can expose time series functions, which is what timescale essentially provides, over the T-SQL language and the SQL Server driver protocol so that we can do time series on SQL Server. And on top of this, all on ARM64. So sure, just go and take Babelfish. You can have here, let's get started on Babelfish. Let's install Babelfish. And well, go and compile it, right? I mean, there are a few instructions here and or some binaries that you may download from here. And then you can, as I said, you can go and compile the source code. There's a few dependencies. It may take you a few hours, to be honest, to compile this. Not forget to compile this on ARM64. And then you also need to go take the timescale extension, compile it also on ARM64 against this source code base, make sure it works well together, and then containerize everything and run it on Kubernetes. Trivial, right? Let's do it in 5 minutes. Well, not that fast, it's not that simple. But fortunately, there is yet another open source project, which is called StackGres. And as a disclaimer, this is software that we're building at OnGres. And StackGres is a platform for running Postgres on Kubernetes. Now, StackGres critically has two main interesting characteristics regarding to this talk that have been added recently. One is ARM64 support. Actually three. ARM64 support, so you can run all your workloads in ARM64. The second one is Babelfish. StackGres introduced the concept of Postgres flavors, and you can use any Postgres flavor that is available right now, vanilla and Babelfish, maybe others in the future, who knows. And one of them is Babelfish, so you can choose whether you want to create a Postgres cluster or a Babelfish cluster. And then StackGres is possibly the platform with the most Postgres extensions available in the world. If you go here on StackGres extensions, you can look there for all the extensions available, and there's hundreds and many more to come. And one of them is obviously timescale, right? So we have timescale here for certain versions on all the flavors support. So by using this combination of Babelfish, the StackGres, and timescale, we're going to be able, or we're going to try at least, to do time series on SQL Server. And well, without further ado, what I would say is, are you ready for the demo? I guess so. Any questions before the demo?
No, let's do the demo. Let's go for it.
All right. All the source code I'm going to use for the demo is public, it's open source, it's on GitLab. So this is the URL, TSOBDF, that's timescale on Babelfish, under my nickname on GitLab. I'll show the slides later on. So let's just go to the demo then. First of all, let me actually bring up my command line. I have created an empty Kubernetes. I'm going to start from scratch, right? To make sure something will fail. I didn't want to bring anything prepared. Sorry about that. So first of all, I just created an empty, is the font size okay, by the way? Maybe something like this. Let's make it a bit bigger. Hope this is okay.
Yeah, and if it's not, just let us know in the chat and we'll make it bigger.
All right, thank you. So I just created an empty Kubernetes cluster on Amazon just before starting this talk. So as you can see, the nodes have been up for 38 minutes, which is pretty much the length of this talk. And there's nothing installed in the cluster. You have to show an empty thing, completely empty thing, just the basic things that you require for having Kubernetes. So the first thing we're gonna do is we're gonna install StackGres on it. I'm gonna also install a prerequisite to StackGres, which is Prometheus Stack, just so that we can also get some monitoring for free. So let me just create a namespace for this called monitoring, for example. And then let me install the Prometheus stack. For this, actually, I'm just going to go to the documentation in StackGres. If you want to do it, just go to tutorial, I always use it. So here in setting up the environment, you can get basically these commands to install this dependency. So again, this is just purely optional, but this is installing Prometheus on top of this otherwise empty Kubernetes cluster so that we can have some monitoring just in case we want to do that, because it's essentially also free and it's also open source. All right, while this takes place, let's just prepare the command to also install the StackGres. It's pretty simple. You need to add a Helm repo, which is probably already added on my computer, and I just need to run this command. All these parameters are essentially optional, just if we want to embed some monitoring components, which I want to. And then this parameter is important, making sure that I want to expose the web console StackGres scans with the web console, which I'm going to be using for the demo as a load balancer. So I'll be able to connect over the internet. So I'm just going to go and copy this command. And whenever this finishes, it's running, I'm just going to use another shell to create another namespace called StackGres. All right. And as soon as this one finishes, I will install the other one. Once we have installed Prometheus and once we have installed the StackGres, then we're going to create a cluster. And the way we're going to create a cluster is to go to the web console. I will fetch the credentials and connect to it via web, and then I will go on the web UI. If you want to do this by yourself, apart from following this tutorial on the documentation, I also recommend you to go to the blog site. And there's a post specifically about how to run in Babelfish on Kubernetes. So you may go and just follow this post also for some additional details on how to run this. But it's very straightforward anyway. So this should finish soon, hopefully. And then we'll be able to take it from here. I hope it will not take much longer. Or otherwise we're starting already with the hard part of the demo. Any questions, by the way, so far, while this command or the next one runs?
What was the inspiration for this? I mean, obviously you're someone who likes challenges, but is there anything that you've done prior to this that kind of matches up with the level that you're going for here?
No, not really. The idea, just comes because we're working on all these components, right? We're working with timescale, we're working with Kubernetes, we're working with Postgres, we're working with Babelfish. And at some point, I just connect the dots, right? Like in this particular case, what I was trying to do is, okay, we are providing vanilla Postgres and Babelfish flavors on top of StackGres. But on the other side, we also have a lot of extensions. And we need to make sure that all extensions work on all scenarios. So for doing this, we just rerun all the build scripts. My team was working hard on this and say, how many of these extensions won't work on Babelfish? Because the difference with Babelfish is that Babelfish slightly changes Postgres behind the scenes, right? So because of these, we might, another extension that also changes some parts of Postgres may not run well or may conflict. However, we were very surprised that there was no such a conflict. And everything worked so far. The extension compiled, the extension passes all the tests, and so it could technically work. I don't know, so to answer completely your question, I don't know where the inspiration really came from. I guess it's just the idea of connecting dots and trying to explore new ways into, like doing time series on SQL Server.
No, and we're definitely fans of that, exploring, pushing the limits, and I think it's a healthy sign to other folks as well too, to try to do the same and to see what happens when these things get mixed together. While we're at it, can I get you to stop sharing your screen really quickly, because we have a very special guest here with us on Zoom. So the other person who is in this call, whose name I shall not name, Angel, can you please share your screen so we can see what you're doing? See if this works. Angel, don't be shy. Let's see. Well, and then we're also getting very innovative here, having 3 people in Zoom at the same time. Angel, if you're there, and if not, we will continue with the demo.
Maybe we need to call him 3 times.
Yeah. Let's see. We can try that. There's the first time for
Bart, Bart,
yes,
can you hear me?
Yes, we can hear you perfectly, but can you share your screen?
Okay, I'm sharing your screen.
Okay, good.
Have you got the screen?
No, I cannot see your screen yet.
Yes. Let me check.
It's okay. You're still on SQL Server. We haven't got ARM64 yet. It's okay.
Go ahead, Álvaro. Go ahead.
No worries, Álvaro. Keep going. Oh, Álvaro, no, I think you're muted.
Oh, sorry.
You're all good. Cool. No worries.
Are you sure, Angel? I'll go back to share the screen.
Oh.
Yeah. Yes.
It should be. It says.
Yes. A minute. Joder. Can you see my screen now?
Yes.
Yes. Okay.
Oh, cool.
I'm trying to do something, Álvaro. My excuses.
No, I love it. Awesome.
I'll draw you with your friend Postgres, always with Postgres, the SQL Server, the ARM64, the Babelfish, and I will continue. Okay.
Awesome. Thank you, Barry.
Perfect. Good stuff, Álvaro. Yeah, you can keep going.
Okay, go ahead.
Yeah, stop sharing if you don't mind, and I'll switch to mine.
Okay.
Thank you. All right. So while you were sharing your screen, the Stackers installation completed. So that's great. Now let's just open the web console. For opening the web console, the first thing I need to do is go to the Stackers namespace and get the service over which this web console is exposed. Because I set up the load balancer, it creates a load balancer on Amazon. So let me just open this. It's going to be the load balancer. Yes, it uses a self-signed certificate. That shouldn't be a big issue. And we should get to the login page. Exactly. The username by default is admin, and the password is generated randomly, but I can get it from with this command. I'm just gonna actually use this one to copy to the clipboard and paste it. So here we go. We are on Stackers. Let's select, actually, let's create a namespace also. Let's call it SQL, for example. And let's select this namespace here to start working on. And obviously, let's switch to dark mode, right? So here we are. This is a really fresh installation of Stackers 1.2, which is what we're going to be using to create our cluster today. Now, before creating the cluster, let me do just a couple of things. The first one is I'm going to create an instance profile. An instance profile is the concept of, kind of a t-shirt size. So let me create an instance profile here. Let's create this small server, which is going to use 4 GB of RAM and 2 CPUs, for example. And that's it. I just call this a small. So this is going to be the size of the instances I'm going to be creating. Pretty easy, created, done. And now I'm going to create a custom Postgres configuration. So basically, I'm going to be loading the timescale extension. And to load the timescale extension, we need to do 2 things. One is to instruct Stackers to actually deploy the code of the extension into the container. But the timescale extension, as many other Postgres extensions, also require to be configured by a configuration parameter that loads the code object for the extension into Postgres memory. It's a parameter called shared preload libraries. So let's create a custom configuration. I'm not going to spend a lot of effort tuning here the configuration, but let's just say I'm going to create a configuration called timescale DB for Postgres version 13. You'll see why. And basically, I'm going to share shared preload libraries equals, I'm going to statements. This is, I always do this. And also I'm going to use timescale DB. So with this configuration, it's a custom configuration, which I will use to later create a cluster. I'm ensuring that timescale DB extension will be loaded into memory of Postgres when Postgres is created. This is pretty usual stuff with many extensions. I create this configuration, everything worked. As you can see, we have a lot of parameters tuned for you, but this is the ones that I'm mostly interested. And now let's just go and create a cluster. So the process is pretty straightforward. Let's create a new cluster. Let's call this TS timescale. I'm going to use a one instance. I'm going to use this new instance profile that I just created. And here's the key. I'm going to select Babelfish instead of Postgres community. Now, Babelfish is considered as experimental. So I need to explicitly mention that I understand, and I use this as my own risk. I may not want to be able to deploy this for production workloads yet, but you know, this is a demo. I'll let it pick the latest version, but as you can see, Babelfish is only compiled as of today up to 13.2.4 in Postgres. So I'll keep it as the latest available, and I'm going to use this timescale configuration that I set to load the extension into memory when available. Let's give it a little bit more room for the disk space just in case. We'll try to load some data, and I'll use the default storage class. And last but not least, I want to load the timescale extension. So this is all the extensions that I can load automatically into my container. By the way, one thing that Postgres does is that because we provide hundreds of extensions, just imagine how hard and how problematic it would be to add all these extensions into the container image. So what you're going to get a 3 GB container image with all the extensions there? No way. And what if one of those extensions has a security bug and needs to be fixed? Then you need to download a new container and redeploy it into production, which means a restart of the database, which means downtime. You definitely don't want to do this, right? So we have developed a new mechanism in the Postgres ecosystem that allows to download and unload extensions dynamically from your running containers. There's actually a talk I gave about this at KubeCon North America last year, if you're interested. You can also find it on my webpage on aht.es. So I just pick extensions. Any moment I want to load, they will be dynamically loaded into the container. So I want to use timescale DB. I want to select a newer version. And with all this, let me just view the summary. So I'm going to create a cluster called TS, one instance with this profile, timescale DB configuration. This, I'm going to enable timescale DB 2.6.1. All looks good to me. Let's just go and create a cluster. And the cluster is being created. I need to wait a few seconds, and the cluster will be created with Babelfish. Now, let's go to the source code of the demo today. Let me bring this up, actually. All right, so what we're gonna do? Well, first of all, we're just gonna test that we can indeed connect here, and sorry, this is the one I wanted. Yeah, sorry, this is the one I wanted, okay. If you look at the source code, you go to the source folder, and we have a program for loading data. So have some deployment scripts that we'll use for loading the data, and we're going to go to the SQL. So here the files are split into some commands that you need to execute from the MySQL side, SQL Server side, and some commands you need to run from Postgres side, and we'll see which ones and why. All right, how is this going? It's pending state. It may take a while to create this cluster. That's fine. Timestamp. Okay, it's being created there. Should be up in a few seconds. Let's go to the command line to start running the jobs anyway. This was called and let's see how it is creating. It's okay. It's ready already. Good. Yeah. So we've got our Babelfish cluster. Let's check that actually. So if we connect here, let's run a command. Let's say exec on the TS0, which is instance and container Postgres util. And let's run a command called usequel, which accepts password and then ms Babelfish at localhost. So usequel is a command line that supports connecting over server protocols. In this case, we're using the MS protocol, which is my SQL Server protocol. And I should be able to connect over the SQL Server protocol. It will probably ask for a password, which let me just retrieve. Password is generated by default, a random password, and it's on a secret that you can get. So here we are. So we are connecting over the SQL Server protocol to Babelfish. We can check this. For example, running this command, you see this is not standard Postgres syntax, right? This is SQL Server syntax. And this is compatibility. You can see that it's created by Amazon. And I can also show that we're running on ARM64. I'm not lying, this is ARM64. Cool. So we've got SQL Server, which is open source, running on Kubernetes, running on ARM64. We're almost there. Now let's go for the fun part. So let's go back to the source code here. We're going to run, and let's look at the first file. So the first thing is pretty simple. We're just going to create schema where we're going to host all of our data. And it's pretty simple. Create schema. We're going to call it schema trading and create it. Now, the next step, let me show you the next step first, is to install so we have already the extension, the timescale extension into the container and load it into Postgres memory. But now, as extensions work in Postgres, we need to run a command, create extension, inside Postgres to create extension. Let's actually open a second connection here and connect to Postgres. Because Babelfish is still Postgres, so I can connect either via the SQL Server protocol or the Postgres protocol. Let's do this, the latter one, sorry. And let's do an exec on TS0, connect container Postgres util, which also contains Postgres binary called SQL. And let's connect to, it creates by default a database called Babelfish. Now, the way Babelfish, there's a small mismatch between what is the database in SQL Server and what is the database in Postgres. Essentially, in SQL Server, you can do cross-database queries very easily, or at least at very low cost, which is not exactly the same case as Postgres. So Babelfish has two modes of operation. The mode we're using here is called single mode, and basically all the data, there's a single database. Let's assume that you have a single database in SQL Server, and any schema on SQL Server is going to create a similar schema on Postgres land. So actually, if I list the schemas here, I will see the DBO and usual and database access of SQL Server, and this one is the one I just recently created. It's master because in SQL Server I'm still referring to the master database, and trading is the name that I used, which obviously should be empty otherwise. So we're ready to create this extension. Unfortunately, to create the extension, I need to run a create extension command. And this doesn't work on the SQL Server syntax. Create extension timescale db. It just doesn't run, right? So I need to go back to Postgres land to run this part of the demo. Sorry, maybe you can believe it's a small violation of abstractions, but this is what we have to do. So let's go back to Postgres only for this one and run the command. Now, it's very simple, just create extension timescale db. But I also need to relocate the installation of this extension to be installed inside of this schema. Otherwise, if I don't do that, the timescale exposed functions will not be available from the SQL Server land. That's it. That's the only thing we need to do. It's pretty simple. I just created extension and bam, we've got timescale on ARM64 on Kubernetes, and we're gonna consume it from SQL Server land. So let's go to the next step, which is to create the DDL for the tables. I'm gonna follow something similar to timescale tutorial online with the small changes that I did myself. So we're gonna create a couple of tables, a reference table with the trading symbols and stock table with information about, you know, some data we're gonna have there. Interesting part is that, well, this here, the Nasdaq symbol is a primary key, so we can use it as to reference, and it will be used as a foreign key here. Nothing special. And we're gonna have this table called stock, which has a date column called ST. This is a column that we will be using to creating the hypertable. In timescale, a hypertable is kind of a way to partition automatically by time the data. And I need to pick a column that is either a date, timestamp, or an integer number. So here we're picking a date. Note that the data types that I may use here in SQL Server, they might not map exactly to Postgres data types. And for example, if you use date time, it will not map to Postgres timestamp. It will map to something called sys.datetime, which is similar but not exactly the same. And we cannot use those data types to create hypertables with timescale because they are not supported. They need to be Postgres direct types. But that's fine. We can use date. We can even use timestamp. In this case, the data do not contain timestamp. I mean, do not contain time information. So we're good with this. So let's go and create this. This is pretty straightforward again. But obviously, we're going to create this from SQL Server land, right? And oh, something happened here. My bad. Let's create this table first. Oh, it's pasting it incorrectly. Let me do something. It's probably because I need to see this raw. I don't want to type this. So probably this is what I want. Let's try this again. Definitely. I don't know how this is pasting this, but okay, let's fix it. Doesn't like tabs, this console. Well, this would work for this one. All right. And for this one, if it doesn't like tabs, let me just reformat this. Demo effect. We need to practice something here. Let's separate by spaces, and probably this should work. Yeah, good. Solve the problem. So we've got the two tables. We're almost done. The next step is to create a hypertable on this stock table, and then we'll try to load some data into it. Now, the interesting part is that Babelfish supports calling Postgres functions from the SQL Server protocol. There might be some type conversions happening, but other than that, we pretty much can call any function. So because timescale functions are already created on this schema, we could technically call them directly. So we could create a hypertable doing something like this. Select, create hypertable on table, it's called trading stock, sorry, blah, blah, blah. Now, the problem is this will be passed down to Postgres, and Postgres will not understand this. So in reality, I need to pass this in a way that matches what Postgres expects, which is this. But this is a violation of the abstraction. Me, from the SQL Server perspective, I shouldn't know that this in Postgres land is called like this. So I'm just going to run it from Postgres for clarity. And so the exact command it's going to be this one. And I'll go to Postgres land and just run this command. Yes, it's not technically correct because I still need to, this is installed in the master trading schema. All right. So I'm creating a hypertable on table stock using the sData column, and I'm creating the chunks by every month. This is because the data comprises many years. So I don't want to use the default, which is a week. That will create many, many more chunks that I may probably, sorry. Now, you may say, Álvaro, you're doing a lot of things from Postgres. This is not SQL Server. You're, doing some breaking a little bit of abstractions here and there. But the good thing is that this is it. I will not go back to Postgres. Everything else will be run from SQL Server. And this kind of installations. Once you have installed this, you're done. Nothing else is required on Postgres land. You can still go to Postgres land if you want to, but other than that, you don't need to. So we have a hypertable already. We can insert data here. So let's actually go and insert some data. Any questions so far? Actually, let me run the data creation commands and take questions right after that because it will take some minutes. So I have here another way to timescale on Babelfish. So I just wrote a small, so let me show you the program first. I created a small program in Java. That's my thing. Sorry if you don't like it. This is a program that creates, inserts data into the database. Now, the interesting part about this program, and you will see here, is that it is using the SQL Server protocol. This is a JDBC SQL Server URL. So whatever, you can inspect the code, you see there's no trick. I'm not connecting to Postgres. I'm not doing anything with Postgres with timescale here. This is just inserting data, and I'm just doing it over SQL Server protocol. Okay, that's the first thing that I wanted to show. And it runs as a command line. And so I'm gonna deploy it in Kubernetes. It's deployed, I just created a small job. Kubernetes, I just need to actually do one small trick here because I didn't build this with all the usual best practices. Sorry, it was for a demo. And so let me just get the password for Babelfish. In this case, I'm gonna hard code it. This is very bad, I know, into this job file, but otherwise I'm not gonna be able to proceed. I accept pull requests. So let's paste here this. Oh no, not this one. Actually, this one instead. And we don't have a lot of time. Let's load slightly less data. All right. So with this, and if all goes well, I should be able to start loading data. So this job, what it's going to do is create in Kubernetes. Let me monitor it, by the way. That's for the to making sure everything's correct. Logs this. So again, this is a Java program that I wrote that loads data on both the symbols table and then the stocks table, getting data from a public data set about stock performance and over the SQL Server protocol. So soon we should be able to start seeing data appearing here from trading first on the symbol table. Oh, okay. Yep, there we have data and it's already loading stock data too. Program is very simple. It's not running on multiple threads. I mean, it could be improved. Sorry that I hard-coded the password there instead of using environment variable. Whatever, it works. It runs. It's compiled as an image on ARM64. It's public, available on GitHub and Docker Hub, and the container image is self-contained. It contains around 300 megabytes of data compressed. Total image size is over 400 megabytes. and just loads the data from inside. And again, if you want to check the source code, it's just here. Data is here, and the resources. Here's the data files. All right, so we're loading data. This looks very good, and we can already start doing some queries. So also on the source folder here, SQL, which is where we created all the DDL structure, we can now start using timescale functions from, let's go this to row mode to open to prevent problems. And let me copy this query and explain later what it does. So we're again here, where we have more than 100,000 records, probably good enough to start doing our query. So here's the query that I want to run. The trick to call timescale functions from Babelfish protocol is just to simply use them as you would do in Postgres, with the small caveat that they are installed inside of the schema. So we always need to use the schema prefix. But other than that, they just work. So here I'm using the time bucket function, which I would say is at the very core of timescale. Time bucket is a function that essentially goes over all the data of a given column, in this case, the date itself. And it's going to create one entry essentially per unit that I express here. And by doing this, actually, I mean, to create a single entry, I need to oh, this is not pasted correctly, but I need to group by on this column also, right? And so what I'm going to do with this query is essentially find the maximum of the height value of all the records from the stock table for Apple. I don't like Apple, but anyway, I chose this one as one of the first symbols that I recognized, and it shows. So basically, I'm going to get, for every week that we have data, the maximum trading value of Apple on a per week basis. Simple, but at the same time powerful, and showing the power of this timescale function. So actually, let me refactor this again. Well, I don't care about this. Let's refactor this text. Let's sit here and let's replace tabs with spaces. I love tabs. That I don't know, I have to take it here that they are failing in this moment. Do you prefer tabs or spaces? Whatever, this will not work. Yep, understood, but this should work. And indeed, it works. So here's the result of the query. And as you can see here, by the use of this time bucket function and then grouping by this column, we're getting a single result per week. And we're seeing the maximum value at which Apple was trading in 1980. Oh, who wanted to buy at these prices, right? And to be honest, essentially, this is it. Of course, you could do much more advanced time series queries, but that's not the point of this talk. The point of this talk is to show that it works. And it works. The only key, after doing everything that we did before, obviously, it's to be able to prefix this with the schema onto which we have installed the timescale extension, and then just use timescale extension. So let me recap. First of all, demo worked. Oh my God, what a relief. I can't believe it. Sounds simple, it looks simple, but I promise you, there's a lot of plumbing behind the scenes. But anyway, it worked. And what we have shown is, A, we can run SQL Server, or kind of, SQL Server compatible. We can run this on Kubernetes. We've been using Postgres for doing this, which is open source also. We're running this on ARM64. There's no tricks, it's all running on ARM64. And then we can install the timescale extension, also compiled for ARM64. And then we can run a Java program that is connecting over the SQL Server protocol to load data. That is also deployed as an ARM64 container onto this Kubernetes cluster and loads the data and use a timescale function to do time series. So all I can say is, from here, it's up to you what you want to do with this. Questions?
If not, as always, this may take a little bit of time to digest. We've done 130 webinars and we've never done anything quite like this. So I think you're setting a very, very high bar. Also very nice to see the integration and use of different tools to achieve this objective. And particularly as well as too, seeing a Postgres person step out of the Postgres comfort zone and into SQL. That's cool too. Let's see, while we're waiting, I will call on Angel again. Angel, are you there? And if you are there, please turn on your microphone. Oh, I need to turn on my camera. Sorry.
Yes.
Oh, Angel, you are here.
Yes, I'm here.
So, Angel, you have been a witness to most of the 130 webinars that we've done. What do you think was different about this one?
Because Álvaro has speaking about Postgres is different. The fourth time.
That's
always, Álvaro always is different. Always is different, and it's very nice speaking about Postgres or everything. Let me. I have to share my.
Yes, you do. Of course, you do. We want to see what you've been doing. We want to make sure you've been busy.
I will try faster than before.
That's good. No worries. We're all connected to 300 different things at the same time.
Yes, sir.
You just make the expectation grow even more. So.
I know. We really want to know.
You have to wait a little bit, eh?
That's okay. We're patient.
It takes some seconds to
click in.
Sure.
Yeah, a little bit of a delay on the.
It's iPad of last generation, but
the original Steve Jobs iPad. Maybe you need to get a new one. That's okay. Let's see.
Here.
Oh, Anka, it looks like you're doing a demo on your iPad.
6, 4.
Oh, wow, this is very suspenseful.
Indeed, can't wait.
Come on, Anka, come on.
Yeah, this.
You need to shake it. Oh my gosh.
Nice.
Here you can see the Postgres land. This is the place favorite for Álvaro. I suppose Postgres land is Ibiza, isn't it?
Of course. What else?
It definitely works for me. I'm not going to say no to that. It's a tropical I don't know if you've seen an elephant in Ibiza yet, Álvaro, but there's a first time for everything.
Not a live one, but actually we bought an elephant's head in Ibiza for our office, which is really cool.
Oh, that is cool.
It's huge. It's like 1.5 by 1.5 meters, something like this.
Oh wow, that's a pretty serious office. Let's see. We got a okay.
Sorry, very very cool. I love the detail of the command line from the use SQL and getting out of the Postgres land to do this super well captured. Thank you.
Good. In the meantime, we do have a question for you, Álvaro, from Michael. This was a jaw-dropping demo of a huge stack in a short time. Where can we learn about how Stackgrass, I believe he says Stangrass, but I think he made it to say Stackgrass is handling PVCs and the like?
Well, what I would say is, first of all, check our docs. They're online, stackgrass.io/docs. And as usual, docs are not up to the level the rest of the code is, but check them out. If you don't find answers, or actually, I would say in any case, we have a dedicated Slack channel that you can find on the website. I suggest you all to just join the Stackgrass Slack channel and ask any question there. And if not, definitely on the DoK channel, you can ask anything or ping me there. I'm going to be there. So Slack, for the most part, I would say, and the docs. Oh, cool, Angel. Very cool.
Very, very good. Oh man, and this is the difficulty of paying too many different.
I can hear you with the mask.
That's okay. Don't worry, we're not saying anything interesting. Yeah, folks, for those of you who were with us live in KubeCon, you did have the privileged view of getting to see wrestling mask, and now I think we're going to have to make this a permanent feature of our webinars. That being said, clear guidance on where to follow up regarding documentation. Get in our Slack, check out the documentation related to Stackgrass. I think now the ball is in Timescale's court to see how they're going to respond to this too. Already got some traction on Twitter from them, so interesting to see what conversations will be born out of this one. Álvaro, you are a Renaissance man. You do things differently. You do it with style. We do need to have a talk about how to give a talk, and you will be invited. I'm not sure if Anka will be invited. Oh, he can hear. That's good. But anyway, got some great feedback here in the YouTube chat as well. Thank you very much, everybody. As usual, check out the links that we mentioned previously about the DoK landscape. You've got more info about StackGres there, as well as the other technologies that form part of the DoK ecosystem. We got the DEI meetup tomorrow. We've got other meetups coming very, very soon in person in London at the end of June. Already talking about when we can get something planned in Spain for DoK after summer. So stay tuned, stay in touch. Álvaro, thank you very much for your time today. And we'll be
my pleasure.